Welcome to lesson 104 of algebraic concept, or lesson 2104. Graph linear inequality in the coordinate plane. Okay, here's our objective, our vocabulary. Okay, so what I wanted to show you is that on a number line, when you graph an inequality, let's say the quality is what? X is less than 3. So you would have an open circle at 3, and then because the variable's on the left, everything would include all numbers less than 3. And the same thing for x is greater than 3. And we include all numbers bigger than 3, not including 3. So now when we talk about a linear inequality, we're talking about a line. And so you're going to need a y is less than 3x. And a dotted line would include all numbers, all points not on a line. The solution will be all points lower than the line 3x. And you will see that when we get to graphing. Okay, so here's another picture of showing what I was talking about. Once you get it into slope-intercept form, even though these are inequalities and not equal signs or equations, you still have a linear function. And so we see this is all things greater than, all points less than, all points less than or equal to. And when it's underlined, it includes the line, all points on the line and above the line. Okay, so the difference here is the points on the line are not included. That's why it's a dashed line. And we will see that as we go through the. Okay, let's get into our first example. Y is greater than negative x minus 4. So find a solution point and not a solution point. So the first thing we're going to do is plot the line, and we're going to find the intercepts. So that's the easiest way to plot a line. So if I put in y is greater than 0 to find the y-intercept for x, I get y is negative 1 times 0 is 0. So we get y is greater than negative 4. So 0, negative 4 is our first point. I could have made a table of values, but sometimes it's just faster to find the intercepts. All right, so for the x-intercept, you put 0 in for y, negative x minus 4. We add 4 to both sides. We get 4 is greater than negative x. I flip things around and keep them on the right. Divide by negative 1. X is greater than negative 4. Okay, so here we go. Now here's our line. It's dotted because the inequality is not underlined. So no points on this line are to be considered. So now we got y is greater than. So that means all points above the line work. Okay, so it says find a solution point and a non-solution point. So to find a solution point, we pick a point. And we will put, let's see, what else will we pick? 1, 1. All right, so let's start with our green point. Okay, so for the green point, we do negative 3, negative 3. Negative 3 for y is greater than negative 3 minus 4. Negative 3, or negative times negative 3 is positive 3 minus 4, which is negative 1. And we know that negative 3 is not greater than negative 1, so that does not work. That does not satisfy the inequality. Negative 3 is smaller than negative 1. As you go further left, you go smaller, even though the number is bigger, even though 3 is bigger than 1. Okay, so let's find a solution. 1, 1. 1 is greater than negative of 1 minus 4. 1 is greater than negative 1 minus 4, which is negative 5. And so that is true. This is a solution. And as we can see, it fits into the solution. So when we solve a linear inequality, all points satisfy the inequality. All points in the shaded region. And the dotted line would be the boundary, or the line would be the boundary splitting the plane in half. Okay, so let's look at our second example. All right, so now I'm going to shortcut this. This is in standard form. And so we know that 2 times 3 plus 3 times 4 should be less than or equal to 9. Okay, 6 plus 12, is this true? 18 is not less than or equal to 9. So this point is not in the solution set. So you might ask yourself, what point is in the solution set? Well, in order to do that, we're going to have to swap this equation around. So the first thing we're going to do is subtract 2x. So you get 3y is less than negative 2x minus plus 9. There's no sign in front of the 9, so it's positive. Divide by 3, divide by 3. So y is less than or equal to negative 2/3 x plus 3. So when x is 0, y is 3. I know from my slope, I go down 2, 1, 1, 2, and over 3. 1, 2, 3. This is from slope intercept. I am less than or equal to, so that means that's a solid line. So my line is like that. It's solid. Every point on the line is included in the solution set. And it is less than. So that means every point down here satisfies the equation. And where's 3, 4? 3, 4 is not in the solution set. 3, 3 is not even in the solution set. But 3, 1 is. And what we can do is to prove that it is put it in. So 2 times 3 plus 3 times 1 is less than or equal to 9. 6 plus 3 is less than or equal to 9. And that's why it's in the solution set. Okay, so that was example 2. Let's look at example 3. Is the point negative 1, negative 1 in the solution set? Again, standard form of a line. So we're just going to solve it. 4 times negative 4 minus negative 2, which is plus 2, is less than negative 1. Negative 2 is not less than negative 1. No, negative 2 is less than negative 1. Yes, it is. I'm sorry. So what is the point? Negative 1 will be in the solution set. So let's graph this line and see what other points are in the solution set. Okay, so negative 2y is less than negative 4x minus 1. We had to divide everything by negative 2. Oh, be careful, that's a negative in front of there. So what this means is that the inequality will flip. Negative divided by negative is positive. Negative divided by negative is positive, plus 1/2. So when x is 0, y is 1/2. We go up 2, 1, 2, and over 1. Up 1, 2, and over 1. And 2 and over 1. So we have a dotted line. And what did we say? Y was greater than. So that means this every point up here. As you can see, the point negative 1 is not quite on the line. It's slightly above the line. So it is in the solution set. It is not on the line because no point on the line will satisfy the inequality. Okay, so those were some examples. Please try to practice problems, and I will meet you at the end of the video for a recap. Okay, determine whether or not the ordered pair is a solution set. So we had this in slope-intercept form, so let's just graph it. When y is 0, when x is 0, y is 3. So 0, 3 is 1 point on a line. We can use our slope, which is 1, or we can find the intercept, which is y is equal to 0, subtract 3, x is 3. Okay, so what I chose to do was do the slope. So the slope here is 1, so that means I go over 1 and up 1. Over 1 and up 1, and that's how I put the points. Less a greater than. All right, so it's a dotted line, which means no points on the line satisfy the inequality. And then let's try 1, 4. 1, 4. 1, 4 is on the line, so let's put it in. So 4 is greater than 1 plus 3. 4 is not greater than 4. That's why it does not, this ordered pair is not in the solution set. So if we were talking about 1, 5, it would be in the solution set. But 1, 4 is not in the solution set. And let's plot 1, 4 in a different color because it is on the line. If this were greater than or equal to, then 1, 4 would be in the solution set, but that is not the case. So we are not going to worry about that. Okay, determine whether or not the ordered pair is a solution set of the linear equality. We're going to divide by 3 on both sides. Y is greater than or equal to -3. I did not multiply or divide by a negative, so I do not have to flip the inequality. -3 is a straight line. It's a solid flat line at -3. So is -5, 2 in the solution set? Yes, it is. Because it's greater than or equal to, so that means all points above the line. And let's put 5, 2 in a different color. So all points above the line. Okay, graph the linear inequality. Subtract x from both sides. Y is greater than -x plus 5. Okay, so when x is 0, y is 5. -x is -1. So I go down 1 and over 1, down 1 and over 1. So these are my points at the corners of each box. Y is greater than. The line is dotted, which means no point on the line works. And the solution set is everything above the line because we're talking about greater than. So that's how linear inequalities work. We're going to do things with these inequalities over the next couple of lessons. So please stay tuned and watch these in the series. I thank you for watching. Please subscribe to this channel if you like what you saw, and I will see you on the next video.